For this problem, we're given a cost function and a demand function. Now, the demand function always connects together a quantity and a price. So being that this is given to us as P of X, that's going to indicate that X represents a quantity. However many are being produced or sold. Okay, so we're asked to find the production level that will maximize our profit. So let's try to set this up and represent our profit function. Now, a profit function is going to be however much money you bring in, we call that the revenue, minus any of the costs that you have to expend. Okay, so our profit function, we already have the cost, but we need to represent the revenue. So revenue is going to be whatever you're charging, price, multiplied by however many you sell. Now our price, we're given that price function, so I can say that's the same thing as P of X multiplied by our quantity, which we said was going to be X, minus our cost function, C of X. Now I'm going to go ahead and call this capital P of X for profit, not to be confused with the lowercase p of X, which was our demand function representing the price. From here, let's go ahead and fill in the information we know. So P of X, the little p of X was 1740 multiplied by X minus, and here's a big key that we want to fill in the whole cost function, but the whole thing has to be subtracted away. So I'm using a big set of parentheses, and I'm going to go ahead and fill in 5550 plus 580 X plus 1.6 X squared, all in a big set of parentheses because all of that cost function needs to be subtracted away. From here, let's go ahead and do a little bit of distributing, still representing our profit function. So 1740X minus 5550 minus 580X minus 1.6X squared. From here, I'm going to go ahead and combine some like terms and put this in descending order. So negative 1.6X squared plus 1160X minus 5550. Okay, so we've represented our profit function. From here, we would like to go ahead and find any critical values or critical numbers. To do so, let's find the first derivative. So power rule a couple times. We'll do negative 3.2x plus 1160, and the derivative of that constant is going to be 0. To find the critical values or critical numbers, we need to set this equal to 0 and do a little bit of solving down. So we'll go ahead and subtract the 1160 to the other side and divide both sides by negative 3.2. So that'll get us X on one side all by itself, and we'll get 362.5. And we can represent that as a critical number. All right, now to determine whether this is going to be a maximum or minimum, we could do either the first or second derivative test, but instead I'm just going to go back to our profit function. In this version, we can see that it's a quadratic, and the leading term is going to be negative, so it's going to be a graph of a parabola, and this one opens down because that leading term is going to be negative. That tells us that we're going to get a maximum at this X value. All right, the first or second derivative test would do the exact same thing for us. The last thing that wasn't asked of us, but we could definitely answer, is we could figure out what is that maximum profit actually going to be. Now we know it occurs at an X value of 362.5. To find what that actual profit would be, we could simply plug back into the profit function. 362.5 gets filled back into the profit function. Replace each one of the X's with it. Negative 1.6 times 362.5 squared plus 1160 times 362.5 minus 5,550. And our very maximum profit we could have with this situation is $204,700. All right, so I hope this helps out as you're given a price function and a cost function and trying to maximize profit. Good luck.